start with position. If I take the derivative of position, that's velocity. If I take the second derivative of position, that is the first derivative of velocity, which is acceleration. So we're just going to go like up the chain. Instead of like last semester we went, took derivatives, we're going up, so we're taking integrals. Then we're going to find C, and then we're going to integrate and find C again. Like you've done this exact process. We're just got to put an acceleration, velocity, position into it. So they give me my acceleration here. So the first thing I've got to do is go from acceleration to velocity. So I've got to, so velocity will be the integral of 12t minus 4 times dt. So that will be 6t squared minus 4t plus c equals velocity. Do you need a writing utensil? And then we're just going to find out what c is. No, I did not want to do that. What do I have? 6t squared plus 4t plus c. So they tell me then the velocity is 18 when t equals 2. So I'll put an 18 there. And then we can find out what c is. So negative 14. Good for c. 24 plus 8 plus
Minus.
what's wrong?
Minus 8.
Oh! Well, I could just erase that. So C is 2?
Yes.
Alright. So that's 24 minus 8 is 16. 18 equals 16 plus C, so C is 2. So then my velocity is 6t squared minus 4t plus 2. And then I just like repeat that process. So I know my velocity function. Now I go to the integral of that and get position. So if I integrate both sides here, I'll get position equals 2t to the third minus 2t squared plus 2t plus c. And then they're telling me the initial position of the particle is 8, so that's when t equals 0. So 8 equals, basically 8 equals c, but I'm plugging in 0 here. So we get c equals 8, then we just like plug that back in. They're saying what's the function x of t? I used x. I used s instead of x, but it's the same thing. So our function is going to be this, but we put in the c that we found. So not bad, right? Like that's the same. We've done that before. Questions on one? All right, second one. Grab a calculator if you don't have it out. So we got a few questions about this graph. All right, this is the velocity. This dude's driving to someone else's house. Star Wars nerds. They're going to. They got this function, so it looks like he started off going backwards, like he was going away first. Maybe that's like back out of his driveway, I don't know. Then he goes forward for a bit, but then he like just says set up the expressions, so like, you're done. You can type it in if you wanna get an answer, but it says just set up. A lot of things, this unit will start to say just set up. It's like, we know you can put in the calculator, so just set it up and we're good. How far after, so make sure you understand, kind of the point of this is that when you're looking at distance from his house, these down here are negative, right? And then that's gonna be positive, so some of the negative positiveness will cancel out. This is like the distance versus displacement thing. So if I go, say that's 10 and that's 10, if I go from A to B and back, what's my displacement? It's 0. Because I just end up where I started, my total distance would be 20, because I walked 10, not 10. That's kind of what they're getting into here. After 15 minutes, that's no different than part A. Just go 0 to 15. You're just setting it up, so you're good. Part C is, again, basically the same thing. How far away is he? How far from his house? That's like the same question. So now you're going 0 to 30 of V of t times dt. Then part D is the one that's a little bit different. So part D, how many miles did he drive? Well, now we want the distance. So now I want like the 20 is in this scenario. So what we're gonna do, you can do this two ways. There's one super annoying way that's a pain in the butt. There's one that's a lot easier. The super annoying way is find these x values. Like let's say that's x equals 0.5. That's like 1.6. That's, I don't know, 2.2. And then you would like integrate from 0 to 0.5. It's gonna come out negative. You would turn it positive because distance has to be positive. You'd integrate from 0.5 to 1.6. That would come out positive, right? You just leave it. You integrate here, it would come out negative. You make it positive. Yes. Yes. But that's a pain in the butt because you got to find out the intersection points. You got to set up 1, 2, 3, 4. You want separate integrals. The easier way to do it. Remember, if you absolute value something, it just makes it so it can't go below the axis and flips everything up. So I'm going to integrate the absolute value of V of t because that would be this graph. And then everything's positive, and I'm just adding those up. So how many miles did he drive? I don't know if that's too low for people to see. Is the integral of from 0 to 30 of the absolute value of V of t. Because then we're saying, well, distance can't be negative, so anytime there is a negative, we're just going to make it positive through the absolute value. So the integral of velocity is which one? Displacement or distance? If I just straight up integrate as displacement. And if I integrate the absolute value, that's going to turn everything positive. So negative distance becomes positive, and then you can add up all of those distances. And I think we've talked about this before this year too, right? Like with derivatives. I think so. What is the absolute value of velocity? Speed. Remember, speed is just, speed always has to be positive. So you're essentially integrating speed when you do that. Alright, 3 and 4. Again, we've done these. There's like an initial condition, and then we're accumulating. So in this context, there's an initial position, and then we're going to accumulate distance. So my initial position is 5. Plus, after 3 seconds, so I'm going to integrate from 0 to 3, the velocity, because if I integrate velocity, I get position. So this is the start. This is how much we traveled. And then you'll get your position. I'm not that worried about doing it, but position after 2 seconds if x of 1 equals negative 2. So that's just like the earlier ones. We're going to have to find out what c is, and then kind of plug in after. So s of t equals the integral of 4t cubed minus 6t squared plus 1 times dt. So s of t is going to equal t to the 4th minus 2t to the 3rd plus t, and then plus c. So now we just plug in those values, right? So the position is negative 2 when t is 4. So that's just negative 2 equals c. 1 minus 2 plus 1 is just 0. So that means s of t equals 2 to the 4th minus 2t squared plus t minus 2. Then what am I supposed to do from there? Plug in 2, because they're saying, okay, they gave me this, like I know this is true. How far is it after 2 seconds? So I'm going to plug in 2, so s of 2. That is a lot of 2's. 16. I think it's 8. 16 minus 8 plus 2 minus 2. Can anybody tell me a different way I could have done that? Might be easier. Comment to you.
Wait, wasn't the t squared in your like s of t that's supposed to be t?
That's cubed, isn't it? So then c is 0.
Yeah.
Okay. So c.
No, it's just like.
Yeah. I got it. Wait, isn't c 2 then?
Yeah, c, well, c is negative 2. And like the answer is 0 of like.
Oh yeah. Because those, okay.
Position.
Yeah, so it's 0. How else could I have done? Try and do it like part A. Slightly different because you're not starting at 0, but you can still use that as your starting position. So the other way I could do it would be to say I know at 1 second I'm at negative 2. Between 1 and 2 seconds I traveled some amount. And that's I can find by integrating the velocity. And that's kind of the same idea as the way we did part A. This is your starting position. We're just starting at t equals 1. That's why there's a 1 here. And then this is how much you would travel in the 1 to 2 second interval, and that would get you to end. You'd end up with the same thing. We just did it like on 2 different ways. Does that make sense? How you can do either one? Okay. Number 4, we're looking for total distance. So total distance means I want everything below the axis to kind of be positive. So I really want like that area, which is 3, and that area, which is negative 3 because it's below, but total distance means we want it positive, so we want to flip it up, and our answer should be 6, because it's like 3 above and then 3 below. If you integrate this from 0 to 4, absolute value, you guys know how to do absolute value in your calculator? There's like that absolute thing. 0, 4. You'll get 6. So if you hit integral and then go catalog, the button that says catalog, it's a list of like every single command in the calculator. I believe it's the very top one is ABS, that's absolute value. Put the negative 1.5t plus 3, because that's what we're taking the absolute value of. Then you tell it the variable we're using and the endpoints. Alternatively, you could go from 0 to 2 and 2 to 4 and kind of make two integrals, but that's just way more work than you need. When the absolute value sign just flips that up, that's the easiest thing to use. Questions there? We're going on absolute value? One person out there had something to go with it. Okay. Questions? Okay, go ahead and get to work. Let's see what we're doing. We'll do number 14, that's a test prep one, tomorrow together. And 13's a good one. So you gotta do 13 for the test prep, but you can try 14.